Dear students, in this module we will learn cumulative frequency distribution and inclusive class. You know that in the case of cumulative frequency distribution and inclusive class, the series has to be converted into ordinary frequency distribution. Whatever be the computation, whether it is mean, median or mode, any measure of central tendency. So this is what we are going to explain in this module with the help of two problems. So one is the inclusive class and second one is the cumulative frequency distribution. So this is important from the point of view of examination because they will not be giving you a direct series. There should be some conversion. So then the problem can be made difficult to compute. So that is what we will usually follow in the examination. So the first one, we will see that how an inclusive class can be converted into an exclusive class and compute median. So the first problem, from the following distribution of height of students, find out the median value. So height in centimeters, 110 to 119, 120 to 129, 130 to 139, 140 to 149, 150 to 159. And number of students, 2, 3, 33, 38 and 9. Why we are calling it as an inclusive series? See the lower limit of the first class. So and the upper limit of the first class. If you take the difference, you are getting 9. Whereas if you convert it into an exclusive class, you will get the class interval as 10. That is easy for further computation. Now we have to convert this into ordinary frequency distribution. So for that we will find out the class boundaries. Class boundaries is upper limit of the second class minus lower limit of the first class divided by 2. So if you take the difference, so you will get 0.5. That is the correction factor. That correction factor you will subtract from all the lower limits and you will add to all the upper limits. So in this slide what you can see are the class boundaries. So then you will get the class interval as 10. So that is easy for computation. So 109.5 to 119.5, 119.5 to 129.5, 129.5 to 139.5, 139.5 to 149.5. 149.5 to 159.5. So the frequency values are there 2, 3, 33, 38 and 9. Now you know that median computation is always based on the cumulative frequency values. That is adding the frequency values. So the first cumulative frequency value is 2. Next is 5. That is 2 plus 3. Next is 5 plus 33. It's 38. Next is 38 plus 38. It's 76. Next is 76 plus 9, it's 85. Now we have to do the computation of median. So median class, 85 divided by 2 because 85 is the frequency total. So 42.5th term. So that is 139.5 to 149.5 is your median class. So this 42.5 we are checking with the cumulative frequency value. That is how you are getting whichever value corresponding to that series. That will be the median class. So median class is 139.5 to 149.5. Now you know that median is equal to L plus N by 2 minus cumulative frequency divided by F into I. So substituting the values in the equation, we will get M is equal to 139.5 plus 42.5 minus 38 divided by 38 into 10. So M is equal to 139.5 plus 1.1842. So you will get median value as 140.6842 centimeters. It's very important when you are writing the final answer, units of the variable should be mentioned. Now the second problem we will do. See, this is cumulative frequency distribution. We have to convert and we have to do the computation. So in a bank, the following were the deposits of savings bank account for December 2020. Calculate median. So deposit balance less than 1000, less than 900, less than 800, less than 600, less than 550, less than 500, less than 400, less than 250 and less than 100. Number of deposits 480, 478, 460, 455, 420, 354, 280, 105 and 5. Now you have to convert this. So the first conversion is 900 to 1000. So if you are converting, the number of deposits is 2. That is first total frequency minus the next class frequency. So that is how you are getting 2. Like that you have to compute other values. 800 to 900 you will get 18. 600 to 800 you will get 5. 550 to 600 it's 35. Now 500 to 550 it's 66, 400 to 500 74, 250 to 400 175, and 100 to 250 it's 100, 0 to 100 it's 5. Now we can put this in the ascending order. So usually I will do the computation based on the ascending order. So the ascending order, we are reversing the table. 0 to 10, frequency value is 5, 100 to 250 it's 100, 250 to 400 175, 400 to 500 74, 500 to 550 66, 550 to 600 35, 600 to 800 5, 800 to 900 18, and 900 to 1000 it's 2. Now we have to calculate the cumulative frequency values, because median computation is always based on cumulative frequency values. So the first cumulative frequency value is the frequency of that first class itself, that is 5. Next will be 100 plus 5, 105. Next is 105 plus 175, 280. 280 plus 74, 354. 354 plus 66, 420. 420 plus 35, 455. 455 plus 5, 460. 460 plus 18, 478. 478 plus 2, 480. Now we have to compute the computation, that is median class is cumulative frequency value divided by 2, that is 240th item. So 240th item meaning you will get the median class as 250 to 400. So median class, now median we can calculate. M is equal to L plus n by 2 minus cumulative frequency divided by F into I. So substituting the values in the equation, you will get 250 plus 240 minus 105 divided by 175 into 150. So here it is 250 plus 115.7. So that is equal to rupees 365.71. See, this variable was number of deposits. So that is why we are writing it as units. So this is what I want to explain with this module. One is inclusive class and second one is cumulative frequency distribution. Both the series we have to convert it into ordinary frequency distribution for median computation. Not only for median, any computation of central tendency. So this is what I want to explain with this module. Thank you.